And here we want to find the Taylor series expansion for tangent of x, center at c equal to 0. And so note that tangent of 0 is 0, and secant of 0, which is 1. And so let's find the first few derivatives, and then see if we can get a pattern. So the function is tangent of x, and if we evaluate it as 0, we get 0. The derivative of tangent of x is secant square of x, and then evaluating at 0, we get 1. The second derivative, which is the derivative of secant square, is going to be 2 secant square times tangent of x, and then the evaluating at 0, this will be 1, this will be 0, so we get 0. The third derivative comes out to be 6 secant to the 4th of x minus 4 times secant square of x. And then evaluating at 0, this would be 1, this would be 1. So it would be 6 minus 4, which is 2. The fourth derivative comes out to be this. And then in the place of x, if we have 0, 0, this will be 0, so that makes this term 0. And this will be 0, so that will make this term 0. And so we get 0. The fifth derivative comes out to be like this. And then now we evaluate it at 0. This is 1, this is 1. So it would be negative 2 times 1 plus 3 times 1, which is 1. 1 times negative 8 is negative 8. This will be 1, this will be 0, this will be 1. So it would be 0 plus 1, which is 1, times 24 is 24. So we get 16. And then the sixth derivative, it comes out to be this long. And then right here, we have 0. Tangent of 0 is 0, so this term will be 0. Tangent of 0 is 0, so we get 0. So this part will be 0, and then here we also get 0 and 0, and so the whole thing will be 0. And then the seventh derivative is even longer. And if we worked it out, it comes out to be 272. And so for tangent of x, this is what we get. The first derivative at f of 0 is 0. Second derivative at 0 is 0. Fourth derivative is 0. Sixth derivative is 0. So all the even derivatives evaluating at 0 will be 0. And then the others will get 1, 2, 6, 272. And so once again, this is the Taylor series expansion formula. Since c is 0, then in the place of then x minus c would be just x. So we just drop the c here. And then f of c is 0. F prime of c is 1. The second derivative at c is 0. The third derivative is 2. The fourth derivative is 0. The fifth derivative we get 6. The fifth derivative we got 16. And then the sixth derivative is 0. And then the seventh derivative is 272. And so right here we get 1x. This is 2, and 3 factorial is 6. So 2 6 will be 1/3. This is 16, and then 5 factorial is 120. 16 over 20, 120 is 2/15. And then 272, 7 factorial is 720. And so 272 over 720 is 17 over 315. And so this is the first 4 terms of the Taylor series expansion for tangent of x. And then the next term is going to be a little bit more involved to get, since it involves the, we know that the 8th derivative is going to be 0 at c, and so we need to get the 9th derivative, the 11th derivative, the 13th derivative, and so on. So this is the formula for Taylor series expansion for tangent of x.